Hello class. Today we're going to talk about scientific notation. Okay, so you're going to need to be able to do two things by the end of this lesson. One, convert scientific notation to standard notation, and standard notation to scientific notation. And here is the standard that we're working on right now. We're expressing numbers in scientific notation, including negative exponents. Okay, now, you're just going to bear with me on this particular recording. I am kind of doing this a little different. Okay, so the only calculator I have available on this one is the one that you see over here to the right. It is one very similar to the one that we use in class, just not quite, but it'll do for what we need to do today. Okay, so first question I have for you for your warm-up is I would like for you to tell me what number sets do the following belong. Okay, so when we look at the first three numbers there, remember we've got natural numbers or the counting numbers. Okay, we've got whole numbers, we have integers, we have rational numbers, we have irrational numbers, and we have real numbers. So I would like for you to tell me what number sets do these three numbers belong. And then when you're done with that, I would like for you to put the following numbers in ascending order. Now yesterday in class we talked about what ascending was. Okay, so I want you to put these numbers in ascending order, please. Just take a few moments and do that. Okay, so let's see how you did. Let me erase these little marks here real quick. And let's talk about these number sets. So it says, what number sets do the following belong? So we've got a 15. Well, the 15, okay, we know that it is a natural number. Okay, because natural numbers are just our counting numbers. So this one is a natural number. Is it a whole number? Yes, it is a whole number. Is it an integer? If it's any one of those, and it's going to be an integer, and it's going to be rational, and it's going to be real. Okay, now the negative 15 over 45, what we may want to do with that one is plug it into our calculator. So if I type in negative 15 divided by 45, so we can see what that looks like, we end up with negative 0.33333333333 as you see on the calculator. Okay, so is that a natural number? No. Is it a whole number? No. Is it an integer? No. Just because it has the negative on it doesn't mean that it's an integer. Is it rational? Yes, because we wrote this as a fraction. So it is a rational, and if it's rational, it must be real. Okay, and then the last one, the square root of 625. So we need to type in second x squared to get your square root, and then 625, hit enter. We find out that the value of that one is 25. So just because it's got that square root doesn't mean that it's going to be a funky number. Now since it's 25, will it be a natural number? Yes. Will it be a whole number? Yes. An integer, rational, and real. So it does encompass all of those. Now, this last question, it says, put the following numbers in ascending order. Well, what does ascending mean again? Okay, we had two words, ascending and descending. And ascending means to go from least to greatest because we want to ascend, we want to climb. Okay, now, when we look at all of these numbers here, we've got to actually come up with their decimal equivalents because I don't know what some of these are. Okay, so we've got to actually come up with that. Okay, so the first thing we're going to do is type in square root of 2. So second square root 2, enter. We end up with 1.41 and then a bunch of stuff. Well, the negative 0.5 is okay. The 7.6 is okay. But we need the 15 over 2 to figure out what that is. So we divide that one and find out that's 7.5. And then we know pi is 3.14. So if I want to put these in ascending order, that's going to be least to greatest. We start with the negative. So we got negative 0.5. Okay, so that's the first one. And then we got a 1.4, we got a 7.6, a 7.5, and a 3.14. Which one's next? The square root of 2. Okay, so that one's out. And then out of these last three, which one's next? Pi. Okay, and then the 15 over 2. And then, of course, the 7.6. Okay, and that's how we put those in order. Okay? So we need to remember the vocabulary word ascending and descending. Ascending least to greatest, descending greatest to least. Okay, so Let's see if we can do a couple things here. So in order for us to be able to understand scientific notation, we have to understand exponents. So we need to understand what this means right here. Okay, now that stands for 3 to the 4th power. So what does 3 to the 4th power mean? Does it mean 3 times 4? No, it actually means 3 4 times. So that really means 3 times 3 times 3 times 3. Okay, now in order to figure out what that equals, because this is our meaning line and this is our evaluation line, what is it going to equal? Well, you can do this a couple of ways. One way, you can do 3 times 3 times 3 times 3 and hit enter, and you find out that you get a value of 81. Well, yesterday we talked about this caret key, the key that the pi is on. And I told you that that was our exponent key. So the way we use that key is we hit 3, and if we hit this little exponent key, notice it gives us a little exponent there. And we just hit the number 4, and then we hit enter. And you notice you get the same thing. Okay, so number 2, what does it mean? Well, 4 to the 3rd power means 4 times 4 times 4, not 4 times 3, but 4 3 times. And we're going to do the same thing. 4, exponent key, 3, enter, and we find out that its valuation is 64. Now, all I want you to do with these next two is just type them into the calculator. Okay, so it's 3 to the negative 4. So type it in the same way we did 4 to the 3rd power and 3 to the 4th power, and then write down the answer for me. Pause the video and write that down. Okay, so let's see how you did. So we're going to do 3, exponent, negative 4, and we hit enter, and we write down what it gives us. It's kind of an interesting thing. 0.0, 1, 2, 3, 4, 5, 6, 7, 9. Only one number missing, the 8. Okay, so then we do the same thing for the next one. So hopefully you did 4, exponent key, negative 3, enter, and you end up with 0.015625. So something's kind of going on here, and that's one of the things that we're going to investigate throughout this lesson today. Okay, now this is the first day of a 2-day lesson. Okay, so we're just going to go as far as we can go. I'm going to go about 15, 20 minutes, and then we'll stop, and then we'll finish up the next day with our assignment. Okay, so here we go. So scientific notation, we need to understand what that means. Okay, scientific notation is a way of writing numbers, and it makes very large numbers or very small numbers easier to use and easier to read. Okay, now there is a format that we use for scientific notation. It is the product of what we call two factors. It's the product of a number here, which is going to be written in a certain way, times 10 to some exponent. And every single time, we're going to do this, okay? Now, we need to understand how to write this number here, and we need to understand how to write the exponent, because you're going to have one of two types of exponents. And if you noticed in the warm-up, we've got positive exponents and negative exponents. And those are the two types of exponents that we're going to use. So let's see what we can do. Okay, so here's an example. It says, scientific notation notes. This number right here is in what we call standard notation. So any number that's just a regular plain old number, that is a number in standard notation, and that's all it is. Well, this number is in scientific notation, and it says the same exact thing. Okay, so that's what we need to understand. We need to understand, how did this number and this number come to be? How are they the same? Okay, so what do you notice in this particular number? Well, I'm hoping that you notice that the numbers here are the same numbers that are here. Okay, so we've got that 184, and down here we've got 1.84. So what we need to understand is that this number in front is always going to be written a certain way. Okay, and it's going to be written in such a way that its value is always going to be between 1 and 10. So it can be equal to 1, okay, but it has to be less than 10, okay? So it's always going to be a single digit here in the front, and then the decimals. And these decimals right here are what we call significant digits, okay? So that's what we're going to be looking at. So this one number, this, let's see, what is this? Let's see, ones and tens, hundreds, thousands, millions, billions, trillions. So this number right here is 18,400,000,000,000,000,000. Well, this says the same thing. So I'm hoping what you saw is that, like we said, the 184 is the same number as this one. But where did this times 10 to the 13th come from? Well, if you really pay close attention, where that comes from is in this original number, the decimal is at the end. Where's the decimal at in my scientific notation number? It's in between the 1 and the 8. So if we actually look at the number of places from this decimal to where we moved it to in scientific notation, there are 13 places. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 places. And that's what that exponent is. Okay? So this number right here, according to this, is called the mantissa. This 10 is our base, and the 13 is our exponent. So let's look at this a little bit closer. So to change a number into scientific notation, the mantissa, that number in the front, must be a value that is greater than or equal to 1, but less than 10. And then we write times 10 to the, because times 10 to the, anytime I multiply a number by 10, it moves the decimal one place. So if I multiply by 110, it's going to move it one place. If I multiply it by 10 squared, or 2 tens, it's going to move it 2 places, and so on and so forth. Okay, so this exponent is going to be the numbers greater than 1 that we're going to count the digits after the first digit. So in other words, we look at this number right here, we're going to count these digits right here, and that's what my exponent's going to be. Because really, I move my decimal from the end to where there's only one number to the left of my decimal place. Okay? Now, if we have a big number, a number that you would like to see in your bank account, that's going to have a positive exponent. Okay? Positive exponent. If we have a small number, so in other words, we've got a small decimal number, that's going to be a negative exponent. Okay, so that's the distinction between them. Okay, so when we were to go back to that warm-up that we had, when we had the positive exponents, it multiplied by 10. But when we had negative exponents, it's actually divided by 10. Okay, so it went the other direction. And that's what we need to understand about positive and negative exponents. Okay, so let's see if we can write a few, just for kicks and grins. So here's our first number. Okay, and this number is, let's see, okay, so this is our thousands, and our millions, and our billions. So this number, if you were to say this one, is 450 billion. Okay? And I want to write it in scientific notation. So the first thing that we do is we look at the numbers in the front that are not zeros. Okay, so I want to write this as 45. And I want to put a decimal in such that its value is greater than or equal to 1, but less than 10. Okay, greater than or equal to 1, but less than 10. So could my decimal go here? No. Could my decimal go here? Yes. Okay, could my decimal go here? No. So the only place I could put a decimal so that the 45 has a value of between 1 and 10 has to go right here. And then we're going to write times 10. And now what we're going to do is we're going to count the number of places that I moved the decimal from where it originally was to where I wanted it to be. So that would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So my exponent is 11. So the hardest part of scientific notation is remembering that this exponent is the number of places I move the decimal and not the number of zeros on my number. Because if you'll notice, I only have 10 zeros, but my exponent was 11. Because for every 10 I multiply by, I move the decimal one place. Okay, so this next one. Okay, so this next one, we've got the numbers that are in front, that are what we call significant digits, are 2, 1, 5. 215. Now, where do I want to put my decimal so that its value is between 1 and 10? Okay, so could it go here? No. Could it go here? No, because that's 21. Could it go here? Well, that's 2, so that looks good. Could it go here? Well, that's 0.2, so that's less than 1, so that one doesn't work. 21 would be greater than 1, and 215 certainly way too big. So the only place that decimal could go is between the 2 and the 1. And then we do times 10 to the, because the times 10 is what moves my decimal around. And then how many places did I move the decimal from where it was to where I wanted it to be? 1, 2, 3, 4, 5, 6, 7, 8. So we'd put an 8. Okay, now you do the last one on your own. Now the last one's kind of tricky just strictly because we have 4 significant digits. So write those down. Place the decimal such that the value of that number is between 1 and 10. Okay, so it's greater than or equal to 1, but less than 10. And then write times 10 to the. And then the exponent is the number of places you moved the decimal from where it was to where you wanted it to be. Okay, let's see how you did. So the first thing, we write 9, 5, 4, 6. Now I need to put a decimal in this number so that that number is between 1 and 10. So the only place it could go is between the 9 and the 5. And then we write times 10. And now how many places did I move that decimal? Let's see, 1, 2, 3, 4 places. So we write it to the 4th power. And that's how you write a positive number, big numbers, and convert it into scientific notation. Okay, so these big numbers in standard form to scientific. Okay, now what if I ask you to go the other direction? Well, the other direction, we just need to remember that this exponent on this 10 tells us how many times to move the decimal. So what you're going to do in order to change a number from scientific to standard is you're going to write 1.34. And then this times 10 to this says I'm going to move my decimal 8 places. So the first 2 are around the 3 and the 4. 1, 2, 3, 4, 5, 6, 7, 8. And then you put a decimal. Now what would I do with all the empty places? You would add zeros. Now if you wrote the number like that, I would count it wrong. Because you'll notice I have a decimal here and I have a decimal here. You're not allowed to have 2 decimals in the number. So we only want the decimal that we need. So this decimal goes away, and all those little humpy bumpy things go away, and you put a decimal at the end if you need it. Now if it's a whole number, you really don't need it. Okay, but we do need to throw in our commas. So there's a comma there and a comma there. Every 3 digits from the decimal point gets a comma. Okay, so the next 2 I'd like for you to do on your own. Okay, you're going to write in the first one, write the 5, 9 down, and then move the decimal the correct number of places. And then the next one, do the same thing with the 7.0324. So pause the video and change each one of those scientific numbers into standard form. Okay, so let's see how you did. So the first thing, I would write 5.9, and I'm going to move the decimal 5 places. 1, 2, 3, 4, 5. Okay, so I'm going to take out this other decimal here. And then I'm going to add zeros into my empty places. And then I'm going to take out the humpy bumpy things. Okay, and you can leave the decimal if you want to or not. And then put in your commas. So this would be 590,000. Now the next one's kind of a tricky one. So we've got 7.0324. And this exponent here says I need to move the decimal 2 places. So I'm going to move it 2 places, and because it's a positive number, we're going to move it 2 places to the right. 1, 2. And so it's going to go right there. So what I do is I come in, I take out the humpy bumpy things, and then put the decimal back where I wanted it. So this one I didn't move it all the way. This one's just kind of testing moving that decimal. Okay, so it's just kind of a crazy one where we don't move it all the way to the end. We don't move it, all the way. We just move it 2 places, and that's it. We've got to do what it says, because that says I'm going to multiply the number by 2 10s. So if I actually did that on the calculator, I would have 7.0324 times 10 squared. We end up with that same exact answer, because all that times 10 squared does is multiplies it by 10 2 times. Okay, so it moves the decimal 2 places. So that's how we change a standard notation number into scientific notation. That's all there is to it. It's that simple. So what if I gave you small numbers instead of big numbers? You'll notice this first number is 0.000000045. So it's a very small number. Okay? What if I wanted you to convert that standard form number into scientific notation? Well, I want you to notice, because this is the standard number and this is the scientific number. What do you notice is different about this form of scientific notation? Well, hopefully you notice that these have negative exponents. So when we have small numbers, we have negative exponents. Okay? And that's what we're going to talk about tomorrow in the next lesson, is how do I convert small numbers to scientific notation and back again to standard notation. Okay, so that's what we're going to look at tomorrow. So today, what we looked at was just going from standard form to scientific with large numbers and going from scientific back to standard with large numbers, which had positive exponents. So tomorrow, we're going to look at what do we do when we have small numbers. So the lesson tomorrow will be a little bit shorter, and you'll have an assignment. Okay? So until tomorrow, I'll talk to you later.